Okay, hi guys. So today we're going to be looking at how do earthquakes and tsunamis occur. So I'm looking at chapter 4.5 from Jacaranda. So a quick revision, what did we look at last lesson in my first video of these? We looked at what are the forces that form mountains. And if you remember, there were three main types. So the continental plates, okay, they can move in three different ways, as I just said. The first one's convergent plates, where the plates are colliding. Divergent plates, where the plates are being pulled apart, and lateral plate slippage or transform boundary is where the plates are sliding together. Okay, that is the result of an earthquake, and that's the result of a tsunami. Both very different, those images, but the actual event of an earthquake and tsunami are very closely related. Okay, so how do earthquakes occur? We're going to first look at that and then look into how do tsunamis occur. Earthquakes occur every day somewhere on the planet, usually on or near the boundaries of tectonic plates. The map in section 4.3 figure 1, which we looked at last lesson and we're about to have another look at, shows a strong relationship between the location of plate boundaries and the occurrence of earthquakes. Okay, so this is that figure. Remember, we introduced you this last lesson. We can see the lines in blue are what we call our tectonic plates. Now, it's like a jigsaw puzzle all around the Earth's surface. Obviously not on top of the Earth's surface, but they're just underneath. Okay, we can see from our key in the bottom left-hand corner, the arrows are where the plates are either pulling apart or together, and volcanoes and hotspots for earthquakes are formed along these lines. So you'll find most earthquakes actually occur on the boundaries of these plates. Okay, so just jump into the last point there. Weaknesses and cracks in the Earth's crust near these plate boundaries are called faults. We also got introduced to that last lesson. An earthquake is usually a sudden movement of the layers of rock at these faults. Okay, so a movement of those faults causes an earthquake. This is a really good image of what happens in an earthquake. Okay, this is figure 1 from 4.5, and we can see in the bottom of that image we have the focus point. Okay, now the point where the earthquake movement begins is called the focus, so that's where the earthquake begins. Earthquakes can occur near the surface or up to 700 kilometers below. The shallower the focus, the more powerful the earthquake will be. So the closer that focus is to the surface of the Earth, the more powerful and the more damage that will be done. So the deeper that focus is, the less powerful it will become. Energy travels quickly from the focus point in powerful seismic waves, radiating out like ripples in a pond. The seismic waves decrease in strength as they travel away from the epicenter. So the epicenter we can see, which is above the focus, is the point on the Earth's surface that is directly above the focus. Okay, we can see the seismic waves coming out as of the result of these two plates moving and sliding against each other. So we can see the direction of the movement, okay, which is going to the bottom right-hand corner. And that is resulting in the earthquake. Okay, so we have three different types of waves that can come out from the focus. The first one is called the primary waves, or P waves. Okay, they're the first to arrive and are felt as a sudden jolt. Depending on the type of rock or water in which they are moving, these waves can travel at up to 30,000 kilometers an hour. The second waves, okay, they're called secondary waves, nice and easy to remember, or S waves. They arrive a few seconds later and they cause a more sustained up and down movement. Okay, then we have a third type of wave, which is called a surface wave. And they radiate out from the epicenter and arrive after the P waves and S waves. So just summing up there, again, we have three types of waves: primary waves, secondary waves, and surface waves. Nice and easy to remember. Just like to show you now an animation that shows the demonstration of those waves. Okay, here we go. So On the left-hand side, we have our P waves. They're the primary waves. They're the first to arrive. Okay, so if I press play, we can see that energy being forced, okay, from left to right. And what comes next is our secondary waves, and as we learned, that causes a more of a up and down movement, and that's what does the damage in an earthquake. It's what brings down buildings, pulls the Earth's surface apart. Okay, so let's play that again. There we go, up and down movement compared to that straight across power from the P waves. Okay, here's a short film I'd like to show you.
The Earth is covered in tectonic plates that slowly move around its surface. Most of the time, we don't feel a thing. The places where they meet are called fault lines, and that's where most earthquakes happen. The edges of the faults are rough and sometimes get stuck together. There is then a build-up of energy as the plates continue trying to move, or come under pressure from other plates. When it becomes too great, the plates suddenly slip, releasing energy in seismic waves that shake the Earth as they move through it. Earthquakes are recorded by sensitive instruments and measured on the Richter scale. It's an exponential scale, which means every number up is a tenfold increase in the size of the earthquake. Earthquakes that measure up to about 4, or with epicenters far below the Earth's surface, are barely felt. At 6, some buildings are generally damaged, depending on the quality of construction and how deep below the Earth the earthquake's origin occurs. Quakes close to the surface produce more damaging energy waves. But even earthquakes this size can be devastating. The one that struck Christchurch in New Zealand measured 6.3, but killed nearly 200 people. In the 7s, buildings can separate from their foundations. Underground pipes may be broken, and there will be visible cracks in the earth. A magnitude 7 earthquake caused the deaths of about 220,000 people when it struck Haiti in 2010. An earthquake measuring 9 or more on the Richter scale will leave almost total devastation, and the energy waves will be visible as they move through the Earth. The earthquake behind the Boxing Day tsunami measured 9.1, and it was a magnitude 9 that devastated part of Japan in 2011. Unfortunately, natural disaster.
Okay, so we got introduced to a really important topic there of the Richter scale. It goes from 1 to 10, and from each number, it's a tenfold. So number 6 would be 10 times worse than a number 5. Okay, we just looked at earthquakes. Now we're just going to take a couple minutes to look at tsunamis. So a tsunami is a large ocean wave that is caused by sudden motion on the ocean floor. The sudden motion could be caused by an earthquake, a volcanic eruption, or an underwater landslide. About 90% of tsunamis occur in the Pacific Ocean, and most are caused by earthquakes that are over 6% on the Richter scale. So that's that connection I showed you between the two photos at the start of this presentation. So a tsunami is the result of an earthquake under the water. Okay, and here's a nice image. I'm not going to go through this too much. It explains the result in a particular tsunami, but there's some great information you can press pause at and look at your own time. Okay, so an important point to understand is that a tsunami is not a single wave. There may be between 5 and 20 waves altogether. Sometimes the first waves are small and they become larger. At other times, there is no apparent pattern. Tsunamis waves will arrive at fixed periods between 10 minutes and 2 hours. Okay, again, here's another short film looking at how tsunamis are formed.
In 2004, the world reeled when a massive earthquake near Indonesia triggered the devastating Boxing Day tsunami. Hundreds of thousands of people died and huge areas of land were destroyed. But where do these monsters of Mother Nature come from? Undersea earthquakes can sometimes cause no damage at all, with tectonic plates moving side by side and nothing but water to feel it. But when plates shift under each other or create a gap, the Earth's sudden movement can displace huge amounts of water. Imagine the ripples caused by a rock landing in a pool. A subduction earthquake under the ocean is the same thing, but upside down. The displaced water is pushed out with great force, forming tsunami waves that travel about the same speed as a plane. Tsunamis can hit land with extraordinary force. Some measure up to 30 metres high. Nations across the Pacific are particularly vulnerable to both earthquakes and tsunamis. Since 2004, early detection systems have been established across the Pacific to measure earthquakes and warn when a tsunami is generated. But the warning can come barely hours before the wave hits. The long-term impact of a massive tsunami can be harder to escape. Potentially fatal waterborne illnesses and sometimes loss of homes and loved ones. In the wake of a devastating tsunami, every moment counts when getting help, food and water to the area.
Alright, and I'm just going to leave this presentation with a few minutes of an actual real-life example of a tsunami. Okay, this happened in 2004. This particular footage is taken from PP Island in Thailand, and it'll go for about 2 or 3 minutes, okay? But I won't be saying any more at the end of this video, so if you'd like to watch on, please feel free.
Plötsligt så försvann allt vatten. Och nu så står alla båtar som ni ser här helt. Sara, hon ser glad ut ändå.
Cô nằm lượt chăng liêu đó, rồi cả mà. Không đập luôn bữa lấy hả?
Die brechen da hinten, und die Wellen, die brechen da hinten auch heftig, oder? Alter Schwede. Guck mal da hinten, Schnicki, wie das hochpässt. Das Wasser. Hammer. Was da hinten abgeht. Nein. Aber da hinten, das ist ja Wahnsinn. Das ist richtig.
ผมรบกวนแจ้งแขกอย่างด่วนนะครับตอนนี้มีพายุ